Hi everybody. I'm going to give a quick update on my truck project. I've got the Megasquirt ECU installed and the transmission controller installed, and I was hoping to do a regular first start video, but it was kind of anticlimactic because I did have bugs I had to work out, and it was a process of trial and error, and finally it came to life. But anyhow, you'll see it running, and everything seems to be working good on it. But I'll show you some details of the installation, as well as some of the things I've learned doing the wiring harness for the fuel injection, and the way I rigged up my wiring for the ECU and transmission controller, wideband controller, and all of that. Well, I decided to mount all the electronics for the engine management and the transmission management as well between the two bucket seats. The passenger seat will go over this area here. This is the Megasquirt ECU. Let me go from the beginning and show you the wiring. Right now I've got the battery temporarily about where it's going to be, and I've got a large cable coming from the positive side to this circuit breaker, 100 amp circuit breaker, and it's got a reset switch. I put it there so that it'll be peeking out from underneath the seat. Now I'm going to build a cover over all of this, of course, but it'll be peeking out from under the seat. I'll be able to open the cover and push the reset button and disable everything. But that feeds into a 80 amp heavy duty relay that's controlled by the ignition switch, and from there that feeds into a main fuse panel that goes to the injectors, the ECU, the ignition, transmission controller, O2 sensor, fuel pump, electric fan. I've got some of the wiring from the ECU harness going onto these terminal strips to distribute it, and I've got the transmission controller here, and this is a separate ground bus bar. It's very important. The sensor grounds are all tied to a common point, and sharing it with the ECU so that you get a good balance on the voltage. You'll get a lot of problems if you've got grounds going in a lot of different directions. This is the ECU that I built. You can see got a gazillion components in it, and all this stuff. What could possibly go wrong? All right, I'm going to show you some of the materials and tools I used on my project here. The first thing that's important, of course, is the wire selection, because this is in an automotive application. It's going to be some of it on the engine. We want it to be heat resistant. I'm using two different types here. The first one you see here is a TXL wire. This one happens to be 22 gauge, but the TXL is heat resistant and is also a very small diameter. When I'm putting it inside of a loom, and I've got for the main harness 37 pins, you can imagine the bundle could get quite large, so using the smaller wire will aid in that. The other one I use where possible is a GXL wire, also heat resistant, but it's more of a traditional size. Now, whatever you do on your project on your car, make sure you're using real automotive grade wire. Not, you'd be tempted to go to Home Depot or someplace and think wire is wire, but it's not. It's much easier to work with, and it's better quality. Next, I'd like to discuss the connectors that I've used here, and the heat shrink, other materials. Now, when you're doing a butt splice, I typically use these closed barrel type connectors. They are a crimp connector, and there's a little depression in the middle, so the bare wire only feeds in halfway. You crimp right on it, and then butt the other end to it, crimp it on, and cover it with some heat shrink. That's when you have like I said, two bare ends. I use these other open type connectors sometimes, where you might be wanting to do like a wire tap into a main wire, and it has to fit over where you don't have access to the ends, and you could crimp these on, and you could put multiple wires out of one tap. Like when I did my main ground, coming out of the Megasquirt ECU is actually 5 small ground wires that get all attached to each other into the main engine ground. So to capture that many wires, I was able to use one of these. Now, like for terminal ends, I buy those. You can buy an assortment off of Amazon or wherever you like. But it's similar to the closed barrel butt connector. They don't have any insulation on them, so you can crimp it. You could test your crimp, by tugging on it, make sure it's on there solid, and then put your heat shrink, adhesive line heat shrink on there. Not only does it seal the joint, but it gives it mechanical strength from being pulled apart. Also, I use some of these weather pack connectors, and they have the pins and sockets are crimped on as well. But these are pretty easy to assemble. It makes, where you have components that have to be unplugged and plugged back in, it makes a nice secure seal. I use that on my throttle position sensor, my cooling fan, my fuel pump, and I'll be using it on other things as well. Now then, to bond everything, I use this heat shrink tubing. This is double wall heat shrink. This one happens to be a 3-to-1 shrink ratio, and it's adhesive line. So when you put your heat gun on there, it shrinks up to 1/3 the original diameter, and the glue gets softened and activates and bonds onto your wire. It makes it really secure, and it seals out the moisture as well. Going on to the tools that I use, I've got just small snippers for cutting wire, and I've got a wire stripper. I'll show you how that's done when I put this on the tripod. I've got various crimping tools depending on the type of connector. Some of them are more specialized than others. Like this one is meant for the weather pack connectors. This one is one I had, and I found it works good for the barrel connectors. And I forget which one this is for. Some of the Molex pins that I use on the transmission controller sockets. And there's a lot of different specialized ones. Sometimes you could make do with what you have. If you've got some extra material and pins to experiment, make sure you get a good secure connection. Demonstration of how I use the wire stripper. The stripper itself has, on one side it grips the insulated part, and the other side you find the proper gauge selection for it, and put in how much you want revealed, usually about 3/8 of an inch or something, and get it in position and just pull it, and it makes a nice clean edge. The other good thing about it, I'll show you, like if you're doing a wire tap in the middle of a wire, you don't necessarily have to cut the wire in two and make another end. You can actually grip it in the middle, and it will bear wire in the middle, and then you could use one of the open the small open type connectors, to put another 1 or 2 wires in. I did that when I was adding fuel injector connectors, multiple fuel injector connectors on one feed wire. Of course, you want to make sure that you've got you have a way to get your heat shrink on first. Otherwise, you're going to have to resort to electrical tape, which I prefer not to do. I'm going to demonstrate how I do my crimps. I have these pliers that have different size crimps built into them. They work a lot better than the small stripper crimper combinations. It's a wider area, so it crimps it in one section. I have marked where I like to use it, but I put it in about halfway. I don't let it go past that first mark, and I take my wire after it's stripped and just twist the ends. Just I don't know if it's necessary, but I do that. Your results may vary. Put the wire in, and then give it a good crimp. It will make a crimp on one side. You could actually fit larger wire in this. They have different ranges for different diameter sizes here. And then do the other side. Same thing. And then, give it a good tug test. It's very strong. And then I use this heat shrink. I'll cut a piece, usually about, if I can, triple the length of the connector. That gives it a good adhesive grip on both wires and will aid in the strength of that joint. And then I use a heat gun. I don't know if you can see, but you can see the glue oozing out the end there. So it's really sealed well. All right, I'll show you how I'm going to do a wire tap into the middle of a existing wire without breaking it in two. This is where you're going to use the cable lug crimp connectors, which are like an open, it's like a U-shaped. I'll show you a bigger one so you can see. This is a bigger one. It's copper or brass, I think. And now this does require a special tool. So I load that into the tool first, and it will form over top. Once the one wire is loaded in properly, you put in the other piece, make sure it goes through, and then give it a good crimp. And if you can see that, those are two joined together. This Megasquirt ECU uses a 37-pin connector here, and now do-it-yourself auto tune right here is where I got my stuff from, and they offered a 8-foot harness, blank harness, which is the connector attached, and then the 37 wires, flying leads coming off of it that you just have to figure out what to do with. But they have very good documentation, and it was pretty straightforward. Also, it takes a vacuum line coming from the intake manifold for the map sensor. I've got everything coming through one access hole here in the floor. This, like I said, this will be under the seat, and you can see there's a lot of components here. But after I verify everything and I'm happy with it, then I'm going to take it back out and tidy up the wiring harness and cover it with like split loom where I can. Okay, I've got the ECU powered up and connected to the laptop where I have Tuner Studio loaded on there, and this communicates with the ECU, and you put in your different settings. Like this is, for example, the fuel map. These are the fuel settings, These are the RPMs, and on the left here is the manifold pressure in kPa. 100 represents wide open throttle, and when you're idling it gets down to about 40, 45. But then these different cells tell it the volumetric efficiency that you're shooting for based on the air-fuel ratio tables. So you've got that. Here's a 3D view of it, roughly. And this is just a base map that I kind of made. You input some parameters into the software here as far as the injector size, the number of cylinders, approximate horsepower at what RPM, approximate torque at what RPM, and then you develop a AFR table, which is here. These are my targeted air-fuel ratio numbers at different loads and RPMs, and this is approximate. This will get you in the ballpark. This won't be the final. Also, you've got ignition settings, ignition table. Here's the ignition table that I'm going to use. This is pretty much like a stock Fox Body 5.0 Mustang. So it goes up to, at wide open throttle, about 36 degrees total advance. But at different RPMs, different loads, those are your numbers. So you have to have some inputs to start with, but this should get me started. Anyhow, let's crank her up. Yeah, I'm not sure where that whining noise is coming from. I'm going to loosen up and take off the fan belts for the alternator, power steering pump, and air conditioning compressor, and that'll disable the water pump as well. See if it goes away. I hope that's it. Otherwise, it could be something out of the transmission, which would be a bad deal. But let me try it again. Well, I think I'm going to have to get a stethoscope and see where that sound is originating from. I really have a hard time figuring it out. It almost sounds like it's coming from the front, but like I said, I disconnected all the V-belts, so it wasn't moving any of the accessories or the water pump for that matter. But, the harmonic damper balancer I did change, so that I don't know if it could be making a noise on the seal. Also, could be the distributor, because it sounds like it's coming from up front to me, but I'm not positive. I think I should get a stethoscope and try to pinpoint it. I do have gauges, and I should check the transmission anyhow, but I don't think that's where the problem lies. Well, this will have to be continued. Well, that's not exactly how I wanted this video to end. I was hoping we would end it with a drive around the yard, but I think I will wait until we figure out what's going on here with that noise. Hopefully it's nothing serious, but in the meantime, thank you for stopping by my shop, and I'll see you next time.